Hi guys, sorry about the lack of audio. So I'm just going to do a really quick run through of what we did in class today, and you can get caught up. So the first thing that I did was, let's see here, let me go back up to the calendar. I will make sure that everybody that was on Google Meets gets credit for the bell ringer. The next thing we did was to review the learning targets. And there is a document that is on your upcoming screen that says physics learning targets. I'll explain this more when you actually have to start working on it. For the moment, I'm just going to go through those. Um, Eventually, what you're going to do is you are going to, as an assignment on this document, you're going to upload a picture that relates to the learning target and then write an explanation for um, how the picture is related to the learning target. All right, so in this chapter, chapter 2, we're going to be able to differentiate between distance and displacement and give an example of each. Interpret motion diagrams or particle models. Differentiate between speed and velocity. Use the average velocity equation to calculate an unknown in a word problem. And just a note here, I will give you equations. You don't have to memorize them. I can create a motion graph of position versus time. I can identify position, displacement, and velocity from a position-time graph. I can differentiate between average velocity and instantaneous velocity. And I can calculate average velocity given displacements, velocities, and or times for a trip. All right, so then back to the board, we went through the 2.1 notes. The 2.1 notes are in the week 2 folder, or excuse me, I should say week 3, or yeah, week 3 folder, chapter 2, week 3. The notes for 2.1 and 2.2 are together. And let me present those. These notes correlate with the book. So again, this first couple of slides goes through some of the learning targets. So skipping to this slide, again, it gives us some of the learning targets. All right, so this chapter 2 is all about motion and how we picture motion. And your brain does a great job of decoding motion. It helps you to determine whether or not an object is moving or whether the background is moving. And because it pays more attention to the object that's moving. So when we talk about movement, we've got a couple of factors that we always need to be able to identify. And movement has directions, and it can be straight line, it can be curved, it can be swirling. In this chapter, we'll focus mostly on straight line motion. And then the other thing that you have to know about motion is an object's position during that motion. So we'll take a look at that as well. All right, so the two key words when we're looking at motion is where and when. Can you place an object in a particular position at a particular time? And we do that usually, or we can do that with a motion diagram. And this is an example of a motion diagram. We see the actual objects in kind of a time-lapsed photo, and we could see that it starts here and it ends here. A lot of times we will represent that motion with a vector because the motion does have a direction. We're showing here that we're starting at point A because it's the flat side of the vector, and the point is where we end up. This is a motion diagram. Okay, in a motion diagram, we are and I apologize, this says motion diagram, a series of images showing the positions. So here's the runner at the next first interval of time. Here's the runner, third interval of time, fourth interval of time. The time intervals are the same, and we're showing the object's position at each one of those time intervals. And we can also determine the distance that the object has moved. Sometimes, though, all of the the moving body parts or the moving parts get distracting. So one way we can simplify this model is through what we call a particle model. And the particle model um, takes a point on each object, a consistent point, and what you see here is an overlay of all of the positions that the runner was in. So in the first time interval, the runner reached here. In the second time interval, the runner reached this position. In the third interval, it reached this position. So each one of these dots represents an equal interval of time. And then the position in reference to the background tells us that this object is moving. Now, if we took time-lapse photographs of a scene and the lamp post was moving, but the runner was stationary, we would just see one runner and we would see the lamp post meeting. So there's always a frame of reference for motion. And part of the purpose of drawing one of these particle models is to determine if the object is moving. So if we just had one dot and the lamppost was moving, we would be able to determine that the person was not moving. And it would probably be more beneficial for us to make the motion diagram from the light post. Okay. So again, let's see, I answered this question. This is just a definition question. It's a series of images showing the positions of a moving object at equal time intervals. And the purpose, again, of drawing a motion diagram or a particle model is to see whether or not the object is in motion. We can calculate distance covered, but the point is letter C. Okay, so those are the notes for section 2.1. And let me just get out of this. And we'll go back to 6. You do have an assignment, and that is to read 2.1 and 2.2 and take notes. If you're taking notes online, virtually, that's fine. One of the best ways to do it is to go ahead and open the text in Kami and mark the text, and then save that Kami document to your notes. Part 2 of Chapter 2 has a lot of terms in it. And so I would really like you to get through 2.1 and 2.2 and get those definitions down and at least have read them and looked at some pictures of what those definitions mean so that on Wednesday we can start practicing talking about distance, position, and displacement. All right. If you go down to the textbook, the first thing you'll see are directions for opening the chapter in Kami. There's a couple of steps you have to follow to be able to get it into Kami and then take notes from there. Okay, that's it. Thanks for your patience. I'll try to have my audio and video figured out for the next time we're going to meet, and I will see you on Thursday.